Hi, and welcome back. So in this video, we're going to take a look at some arithmetic operators that we can implement using these special dunder methods. So we have, for example, the dunder add method. That's to implement functionality for the plus operator. We have the same thing with subtraction. We have got the dunder sub, we have the dunder mul for multiplication. Then we have division. Now there's two types of division as we know. We have true division, which is that single slash operator, but we also have floor division, which is the double slash. So you can think of it as, let's say, integer division, right? But of course it uses floor division. So again, we can implement this operator. It is an operator, the slash slash. It's two symbols, but it's a single operator. Can be implemented in our own classes using the dunder floor div method. We can also implement the modulus by using the dunder mod. Power, the double star, we can do using the underscore POW. There's also a new operator called matmul, which is really this operator over here at. Now, this is new in Python 3.5, and Python itself doesn't actually have anything that implements this operator anywhere. It was really added for better NumPy support, which does implement this for matrix multiplication. So we can use this operator as well, even though Python doesn't have it defined, let's say for lists or things like that. We can certainly use it in our own classes. In fact, that's of course what NumPy does. So when we want to indicate that an operation is not supported, then we implement the method and we return the not implemented special constant. So be careful with this. We don't raise an exception. If we want to specifically identify that, let's say, the addition operator between our classes is not implemented, then we can do it this way. We implement the method and return not implemented. Now, of course, we don't have to implement the method at all, but there are cases where we do want to do that, and I'll show you that in the code. Now we have also the reflected operators. So let's talk about this. Let's look at a plus b. What Python tries to do here, it's a binary, plus is a binary operator, and it starts with the left-hand operator, and it tries to find the dunder add method of the left operand. And then it calls that, passing in the right operand as the argument to the add method. But if this returns not implemented, not if the method doesn't exist, if it returns not implemented, and the operands are not of the same type, that's important. Both of these things have to be satisfied. This add method should be implemented and return not implemented, and the operands should not be of the same type. So A and B cannot both be instances of the same class. If that's the case, then Python will swap the operands and it will try this instead. So in other words, it's going to start with the right operand, but now it's going to call the special method called right add, and then pass in the left operand as the argument. So we have our add, our sub, our mul, our true div, our floor div, our mod, our power, right? So all these operands also have these reflected operators. So again, in the code after this video, I will show you where this actually could be quite useful. Now we also have the in-place operators, and the in-place operators are things like the plus equals or the I sub for minus equals. And then we have the same thing for the other ones, times equals, div, the true division equal, the floor division equal, the mod equal, and the power equals. So again, I'll show you that in the code section. We also have a couple more that I want to show you. We have two unary operators, negation, which is when you say minus a. This is not the same thing as subtraction. This negative here is basically a unary operator. It's an operator that takes a single operand and it operates on this operand a here. So when that happens, the dunder neg method is going to get called. We also have the plus. That is also an operand. Plus a is actually an operand, and it can actually do something with your class if you wanted to. And then we have the absolute method, the dunder abs method. That's used by the abs function that's built into Python. So again, we can actually implement functionality so that our classes, our objects, can support the abs method if we want to. All right, so let's switch to some code and let's actually work with all these different special methods. So thanks for watching, and I'll see you in a bit.